What's up everybody, how's it going? In this video, I am going to be putting your JavaScript skills to the test. That's right, in this video, I'm going to be giving you a 7-question JavaScript quiz that I've created myself. Now the 7 questions that I wrote are not questions that test really weird JavaScript trivia or kind of like obscure implementation details of JavaScript, like, I don't know, something like, when you add an empty object and a number, it gives you a string or something weird like that. No. Instead, I created these questions to really assess things that I think are pretty commonly used in production level JavaScript, the kind of stuff that you actually run into day to day. And so, yeah, hopefully it'll put your knowledge and your skills to the test. It is a pretty difficult quiz depending on your level of experience and depending on how much attention you give to it. As you'll see, there are a few, curveballs, to say the least. I don't want to spoil anything. But yeah, I would encourage you, if you are even remotely familiar with JavaScript, to take the quiz yourself. So basically, I'm going to walk you through the 7 questions. I'll give you 3 seconds to pause the video, answer the question, come up with your answer, and then at the end, or after you've paused the video, I guess, so in like 20 seconds, I'll walk you through the 7 questions and we'll go through the answers and explain how they work. I suppose the last thing that I should say before we dive into it is that basically all of the questions have some code that you have to look at, and then at the end, they console.log something or multiple things. And so your task is to either tell me, or I guess yourself, what the code outputs, what it console.logs, or perhaps to determine if there's actually a bug in the code and if an error is going to be thrown. So that's what you have to do. With that, let's dive into the quiz. See how many answers you can get correctly. So I'm going to give you a few seconds for each question to pause the screen, answer the question, and then we'll dive into all of them. So let's jump into question number 1. This is question number 1. So take a few minutes or a few seconds to pause and answer the question. This is going to be question number 2. Again, take a few seconds to pause the question, look at it, give your answer. Okay. This is going to be question number 3. Pause the screen, try to answer the question. Question number 4. So here I might just zoom out a little bit so that you can see the full code. This is question number 4. Then we've got question number 5. So this is a pretty long one. So I'm going to scroll down slowly here. You might want to pause here and then I'm going to scroll down to this part, second part. So you want to pause here. Then question number 6, I think we can zoom back in here. This is question number 6. And then finally, question number 7. I'll zoom back out again here and I'll scroll a little bit. So this is question number 7, like the first part, and then the very end. Okay, so at this point, if you're watching right around this timestamp in the video, you have either decided that you didn't want to take the quiz and you just want to go straight to the answers or to the walkthrough, which is totally fine, or you have taken the quiz and you are now eagerly waiting to see the answers. So let's go all the way back to question number 1 and go through them together. So question number 1, I think, is probably the easiest out of all of them, although I didn't actually order them by order of difficulty. But the reason that I think it's pretty easy is because it really just tests your knowledge or your understanding of the reduce function on arrays. I think that for beginners, most beginners have only ever seen or used the reduce function when they're trying to sum up an array of integers or of numbers, because that's what you typically use the reduce function for. But really what reduce does is it just gathers like a group of elements in an array, and it reduces them to one value, right? It accumulates them and does some sort of logic into one value. And so here what we're doing is we've got this array of objects, and these objects have the properties x and y, and it reduces the array of these objects into a single object, a map, that maps every x value, so every x property, foo, baz, here, b.x, to its corresponding y value, b.y. And so the dot reduce function here takes a beginning element, and this is an empty object here. And so here we pass in, or we return, we destructure that empty object and grab its properties at every iteration, because A is the accumulator. And then we take b.x, which is the property on each individual object, and we put b.y. So if we run this, node question1.js, you can see foo bar baz, and they all map to their respective y value. So again, pretty straightforward. If you know how reduce works, you should have gotten this one correct. Make sure to keep track of your score. So okay, now let's move on to question number 2. Question number 2 is kind of a fun one. It's possible that you've gotten an error if you don't know how some of these things work. So basically we've got array 1 here, which is just an array of objects where every object has a name property, foo bar baz again. And then we've got 3 arrays, array 2, 3, and 4, that are created basically based off of array 1. So the really tricky one here, in my opinion, is array 2, not array 3 or array 4. Because array 3, if you look at it, you're literally just mapping array 1 to a new array. And for each object, you are returning a new object, right? A new object here, and you're destructuring the object that you're currently at. So you're destructuring, for example, this object or this object, right? Meaning you're grabbing its name property, and then you're also adding a position property with the index that you're at. So array 3 should create a new array. It's going to have all these objects where every object has an additional property, the current index, and array 3, the way it's currently written, will not mutate array 1. Now array 4, there's a little trick there. Some of you might have fallen prey to it. It's the fact that we are slicing array 1, so we're making a copy of array 1. But then, for every element in this copy of array 1, which is now array 4, we add a position property to it. So the same thing that we did here, but the trick is that when you slice, you are making a shallow copy. So you are not actually recreating all of these objects here. You're actually just making a copy of the array, but the array is carrying or pointing these objects here. So for example, if we had something like const a equals name foo, and we put a in this array, here, array 4, when you do array 1.slice, even though array 4 would be a different array compared to array 1, it would still have the same exact a value as array 1. And so here the trick was that array 4 actually is going to mutate array 1. And so when we console.log array 1 here, it should actually look in the output exactly like array 3 and array 4. So those were the 2 things with array 3 and array 4, but array 2 is the trickier one. Because array 2, we create a brand new array of the same length as array 1, then we fill that array with empty objects, and then for every object, we seemingly add a name property based off of the corresponding object in array 1, and we add the position. So you would think, okay, this is just like we're doing the same thing effectively as array 3, right? And we're not mutating array 2. But that would be incorrect. The reason is that when you do new array, or not new array, when you do dot fill on an array, the value that you pass to dot fill is actually going to be the same exact value passed to every single position in the array. So here, we're not creating a new empty object in every position in the array. We're filling the array with the same exact empty object. Kind of the same thing as with the slice, like same kind of logic, where it's the same empty object. And so here, when we do object.position equals idx or object.name equals name, we're mutating the same object. So when we're at the last index, we're actually mutating the object that was at all the previous indices. And so that means that for array 2, we're going to end up with an array that has all the same objects, and they're all going to look like baz, name baz, with index or position 2. So let's actually run this, node question 2, and you can see, so array 1 did get mutated with the positions 3 and 4 are as we'd expect them, but the mutation happened because of 4. And then finally, array 2, like I said, it's all baz and all position 2, because these objects are all the same. They're like 3 pointers to the same thing in memory. Okay, so let's move on, but make sure to keep track if you got it right. So let's go do question number 3. So question number 3 is a little bit tricky with a bunch of promises. Now, the main trick with question number 3 is not what you might think it is. You might think that I was trying to test you on, do you know that these objects, like foo object here, and then like the return values in these promises, which seem to be the same objects and seem to be mutated inside these promises, are they all the same? Do they all get mutated? And the answer is yes. Like here we instantiate or create these 2 objects. Then we have these 2 promises that resolve into these objects. One of them has this fancy set timeout, meaning it's going to resolve in 3 seconds. Doesn't really matter. Then we do a promise.all, but we edit or mutate these 2 objects. We add plus is an algo expert, plus is a systems expert to both. By the way, if you're a software engineer preparing for your coding interviews or your systems design interviews, then do check out my company, Algo Expert. Go to algoexpert.io and use the promo code CLEM, CLEM, for a discount on the platform. So the point is, here, we first mutate these. So by the time that the promise.all, or rather the 2 promises resolve, these objects will have been mutated. And I guess we hit this console log at the bottom on line 32 first. So we're going to console log these 2 objects with their mutated names. Then we get into the promise. We console.log the 2 kind of original objects. They have the mutated names again. Then we console.log foo and bar, the values that are returned by the promise. Same thing, right? They're the same exact objects. Then we seemingly mutate foo and bar with is an algo expert, some sort of boolean that does this, foo.name.includes algo expert. Then we return these 2 objects again, another dot then, but here is the problem. By now, there's already been a bug, and so we're actually going to break out of this promise, or of this dot then, and hit this dot catch here, and console.log there was an error, and the bug happens here at foo.isAnAlgoExpert equals foo.name.includes. Now, the reason there's a bug here, and this is where, like I said at the beginning, you really need to be paying attention, is that when you do promise.all, you pass in an array of promises, which I do here, right? I pass an array of promises, and then the return values is going to be an array. And here, I didn't put an array. I just had foo and bar. So what's going to actually happen in this code is that foo is going to be the entire response of the promise.all. So foo is actually going to be an array of foo and bar. That's what foo is going to look like. And bar here is just going to be undefined. And so you can see, if I actually run this, right, node question 3, there's the delay because of the 3 seconds. Foo is an algo expert, bar is a systems expert. This is from line 32. Then we hit line 14. Line 14 is the same thing. Line 15, foo, like I said, is the actual array response of promise.all, whereas bar is undefined. And then we do foo.name.includes. There is no .name property on this array here, right? An array doesn't have a .name property. It's undefined. And so when we do .includes, you can't do .includes on undefined. And so you get you get an error, and so you hit this catch, and that's why we have this here. Kind of a tricky one, kind of an annoying one, because I'm sure that some of you actually know that promise.all returns an array, and you might not have seen that I wasn't returning an array, but this is something that I've actually faced in a real code base. Like back when we weren't using TypeScript on Algo Expert, when we were using JavaScript, and you're not told that you have an error in JavaScript here. I ran into this issue, and I remember I was super confused, like what's going on? Like my promises seem correct and all that, and it's because I was missing the brackets. I'd forgotten to basically add the brackets, right, and return an array. So just something to always keep in mind. So let me clear this terminal, and let's move on to question 4. Okay, so question 4. This is an interesting one, and it's something that I've seen some people make the mistake of doing. So pay attention if you got this wrong. Basically, we have a candidate, which is some object with a bunch of properties. Seems like a candidate applying to a job or something. And then we've got this one function, getSignedOffer, takes in a candidate, and it has two possibilities, right? If the candidate isn't looking for a job or the candidate isn't remote friendly, and these are properties here, then we return an object that has an error message, the candidate doesn't meet requirements, and the offer is not signed, and then we return the candidate in that object. And if one of these conditions or both of these conditions are true, then we return this object, right? With no error, the offer is signed, and some more information on the candidate. And so that's what we have to console.log. So at first glance, this seems pretty easy, right? Okay, getSignedOffer takes in the candidate. Our candidate is looking for a job. They are looking for a job, so not looking for a job. And they are remote friendly, so we're not gonna hit this condition, right? We're not gonna hit this. We're gonna go down here, and so we're gonna return this object. So this is what we're gonna console log. So no error or null. The offer is signed, and then the candidate seems like we're setting is looking for a job to false because it was true. Then we're grabbing all the rest of the candidate properties, and destructuring them, right? So re-adding them into this object. Then for other info, we're grabbing all of the stuff in other info except is employed, where we're setting it to true now because it was false. Because now the candidate has signed the offer and they're employed. So yeah, that's what you would expect to be returning, right? But no, that's not what you get. The reason is because of this is looking for job. So it turns out that everything that I said is correct, except is looking for job is actually still going to be true when we run this code. And the reason is that when you destructure an object like this, it will overwrite any properties that it has inside of it that you might have declared above it. It'll overwrite them. So here is looking for a job is in the candidate object. So when we destructure candidate, this is looking for a job will overwrite this one. Whereas here in other info, we correctly put is employed true below the destructuring of candidate.otherInfo, which has is employed false. So here is employed will overwrite the previous one, but here the candidate is looking for a job will overwrite this one. So if we run this, why did I have, oh yeah, I had this edited. But okay, so if we run it, node question 4, you can see is looking for a job true. Whereas if we move this just one line below, right, and we rerun it, then is looking for a job false. So this is something that's really important to keep in mind. You always want to put properties, or typically it's just easier to avoid bugs to put properties that you're actually hard coding when you're destructuring an object, put them under the destructuring of the object, and you're going to avoid this type of bug. You often have to do this if you're working, for example, with Redux, so just something to keep in mind. Okay, so that's 4 questions. How many questions are you at so far? Keep track. So now question number 5, so this is the really long one. So question number 5 is, again, kind of like the previous one. It has you kind of follow the code to figure out what path we're going to be going down, and it seems kind of straightforward. So basically, we've got this function, get application eligibility. We've got a big data object. This other object existing applications. So then we look at what our actual code is doing. We're grabbing a bunch of variables or declaring variables or constants off of the data object. Depending on a condition, we call this get application eligibility function. Otherwise, we console.log this. So let's see, is looking for a job off of the data object. It is true, okay? And then company.info.humanresourcesinfo.hasJobOpenings is true as well. So this condition seems to have been met. So we're going to call this function with the person ID here, the age of the person, and the company ID. Okay, these are all values in the data object. So then in here, get application eligibility, we follow the code. Is the age smaller than 18? No, our age is 26. Okay, so we're going to skip this. Do we have an existing application at the company ID, which is 7182, which is right here, dot includes candidate ID, which was 517. So is 517 in this array here? No, it's not. So we're not going to hit this line. So presumably, we would hit candidate can apply. That's what the code tells us once you follow it, right? A little bit complicated, but that's where we end up. But there's a bug in the code. So if you said this is what we're going to get, that was incorrect. The bug is that we're going to have a flat out error. And the bug is here, company.info. So the way that we declare these constants here, we're grabbing the ID on the person object and naming it person ID. We're grabbing the age, grabbing the company ID, or the ID on company object, naming it company, grabbing is looking for a job, but we're not actually grabbing company. All that we're doing with this notation is grabbing the ID property on the company object and calling it company ID, but we're not grabbing company. So if I run here node question 5, you can see company is not defined. And so we would have to also declare company here and then run the code, and here it would work. Candidate can apply. So this is something that you're not going to encounter all the time, but the more you work with kind of like nested objects and stuff like that, the more you might actually encounter it, because you might find yourself having to destructure a big object like this, and you might forget to, declare a certain constant. And so, yeah, if you're working not in TypeScript and the compiler doesn't tell you immediately, like, hey, or the TypeScript stuff doesn't tell you immediately, like, hey, you've got an error, then you're gonna have a bug, a bad bug. Okay, so that was question number 5. Now let's move on to question number 6. So question number 6 is kind of a silly one or annoying one. It really has one trick, in my opinion. So first of all, it has you follow some kind of complicated or convoluted logic, but if you're following, closely, you'll follow it correctly. But then there's one trick in this first part, this foo part, and I'll dive into it in a second. But I guess let's cover bar first. So bar just takes this array number 1, concats it to array number 2, meaning it merges the two arrays, but if you know how concat works, it creates a brand new array with the values of array 1 and array 2. And then it checks for the equality of this value to this value, which is another array, brand new array, that destructures all the values in array 1 and array 2. So basically here, I'm just testing whether you know that you'll have two identical arrays, but that are not actually pointing to the same thing in memory. So this will be false here. This will be false. And then we have an OR. So if this is true, then all of bar could be true. So this here, if I remember correctly, is not true because we are reducing the first array. We're multiplying all the values and starting with an accumulator value of 1. But if we multiply, we have a 0 here in array 1. So this entire thing here is going to be equal to 0. On the other hand, in array 2, we add the numbers, but array 2 only has zeros, so we're adding a bunch of zeros, but we also start with 1. So this is going to be equal to 1. And so 1 is not equal to 0, so this is false, so bar is false. So here, this is false. Now for foo. Foo, a lot of you probably said false for foo. You probably walked through the code, double-checked your calculations, and you concluded that, yeah, it's false, but it's not false. So why would you have said false? Okay, because we have foo equals array 1 destructured, so we're basically just copying array 1. Then we filter array 1, and we only grab the elements in array 1 that when you mod them by 2 equal 1, meaning all the odd numbers, right? When you divide them by 2, the remainder is 1. So basically, here I'll write it below, you would have 7, 15, 1, 7. That would be your array 1 after the filter. Then you sort the array. So presumably you would have 1, 7, 7, 15. Then you slice 0 to the 2, but 2 is excluded. So basically you grab the first two elements, so 1 and 7. Then you map them to those elements plus 5. So 1 plus 5, 6. 7 plus 5, 12, right? And then you check if sum, dot sum, is any element in the array, does it satisfy this condition? where that element is greater than 15. And 6 is not greater than 15. 12 is not greater than 15. So you presumably said false, right? No. Why no? Because like what I said is just objectively true. Well, the error is in the dot sort. You see, in JavaScript, because JavaScript is fun like that, dot sort by default, if you don't pass in anything, will first convert the values to strings. And so it'll sort the strings lexicographically, meaning that the number 15 here, 15, like this, comes before the number 7, or before the number 2, which itself comes before 7. Why? Because 1, lexicographically, or like the Unicode value or whatever, comes before 2, comes before 7. So when you do dot sort on this array, you actually get, I'm pretty sure you get 1, 15, 7, 7. And so if you get this, then when you slice and you take the first two values, you get 1 and 15, not 1 and 7. When you add 5 to 15, you get 20. And so 20 is greater than 15. So you've got one value that's greater than 15. And so foo is true. And so here, if I do node question 6, you can see true and false. Now, how would you fix this? Well, you would pass in a comparator function in the sort function. And so you do A, B. These are the two elements at each sort of like sorting comparison. And you return A minus B. And you can look at the Mozilla docs to see like what the return value of the comparator function has to be to determine the sort order. But so if you do A minus B, then you run it, now you get false. Excuse me. So now you get false because now you actually sorted the array. And then the logic that I described just before ensues. So that's question number 6. Like I said, kind of an annoying one. Like the main trick is this dot sort. Maybe you got caught by some of the other things. Maybe this thing, the array comparison caught you, or the reduce with the starting value. But this was the really tricky one, the dot sort, that I know I have fallen prey to sometimes, in a production code. And here, like TypeScript will not save you for this, right? Because dot sort without a comparator function is also correct. So this is something that you really have to just know, or, run into a bug with this, bang your head against the wall, and then figure it out yourself. Okay, so now last but not least, question number 7. So question number 7 kind of follows the same theme that we've had throughout this quiz, which has to do a lot with like, copies of objects, of arrays, whether you're mutating the same array or the same object or whatever, overwriting things. So basically, we've got this create person function that takes in a name, a location, and interests. And we first create a person by basically referencing this default person object, which seems like kind of, a default structure for a person in code. We destructure this object. And then if we have a name that we actually passed to this function and not like undefined, then we set the person's name. So we effectively overwrite unknown. Same thing for location, same thing for interests, and then we return the person. And then we've got 3 methods. Set name takes in a person and name, set location, person location, add interest, person interest. And we overwrite the name, overwrite the location, or push an interest to the list of interests that the person had. Okay? And so then we create 4 persons. So Elon Musk, Jeff Bezos, Bill Gates, and Mark Zuckerberg. And you can see for some of them we passed undefined, right? And then we add interests and set names and set locations to all of them. And so basically, if you naively read the code, then you would expect that eventually Elon has as interests, Tesla, space, and renewable energy. Jeff Bezos is on the moon, and he has Amazon, space, renewable energy, because he has Blue Origin, so that's why he's interested in space. Bill Gates has Microsoft, renewable energy, medicine, and he's on Earth. And then this last person is indeed Mark Zuckerberg on Earth, likes Facebook and medicine. And when you console.log them, you'll see that this is actually incorrect. So you'll see that I think the error here is that, Jeff Bezos and Mark Zuckerberg have like duplicated interests. So question 7, yeah, you can see Jeff Bezos has Amazon, space, renewable energy, but then he has Facebook and medicine, and Mark Zuckerberg has the same things as Jeff Bezos. Why? It's because of this. When we destructure this object here, destructuring is always a shallow copy. It's the same thing as like dot slice, for example, for an array. And so we're destructuring all these properties here, but we're making a shallow copy of this interests array. And so here, when we don't have an interests, when we create a person, so for Jeff Bezos and Mark Zuckerberg, we passed an undefined for the interests, we keep this same array of interests for both of them, or for any other person that we might add that has undefined interests. And so when we then add interests, we are naively pushing interests to the same array. And so that means that, they have duplicated interests or, conflicting interests, and that's really not good. And this is, kind of an elementary mistake, if you will, but it's a really bad one. And it's one that sometimes, it'll escape you and you will forget about this. And you really don't want to forget about that because that can really cause like nasty bugs in your code base. And this is the kind of thing where like TypeScript will not save you either because none of this here is particularly like incorrect. And it's very often the case that you will do something where you have like a default structure or something like that, and you do something like this on line 8, and you just got to be careful with this. Like here, you would probably want to do something like, interests and reset the empty array. And if you did that, then let's rerun this. Then suddenly, there you go. Jeff Bezos and Mark don't have the conflicting interests. But so, yeah, that was question number 7. Kind of a tricky one again with the whole shallow copying and all that. Hopefully, you got it right. If you didn't, hopefully you learned something. I'm very curious. How did you do on the quiz? Let me know in the comments below. Let everybody know. It'll keep yourself accountable what your score was. How many questions out of 7 did you get correct? And which ones did you get wrong? And I think I said this at the beginning, but if you did get a couple questions or even a lot of them wrong, don't feel bad about it, right? This is a great way to like learn. These are questions that you'd rather learn now than on the job or in a real production like bug. And yeah, hopefully you enjoyed this video. I had kind of fun making this quiz. It was actually like relatively hard to make, to come up with like seemingly non-convoluted and good questions. Hopefully you agree that these questions are not super obscure or like trivia. They're actually, legit JavaScript. And yeah, if you enjoy the quiz, don't forget to smash the like button for the YouTube algorithm. Comment down below your score like I said. Subscribe to the channel if you haven't already. Follow me on LinkedIn and Twitter if you enjoy short form written content. Instagram if you like pictures, and otherwise I will see you in the next video.